calculator and graph it. We're going to adjust our window so we can make sure we can see all the important parts of the quadratic. And then this chart here is just for you guys to kind of keep track of what we found on our calculator. So the main things we're going to figure out, how do you find out this information about a quadratic on the calculator? We really want to find out the vertex and the x-intercepts. That means we could use the technology to help us find maximums and minimums, or we would enable ourselves to find the solutions if needed. Okay, so those are the things that we're looking at on here. So we're actually going to figure out what those values are and record them, and then you can write down any of the buttons that we push or notes that are helpful to you while we're using the calculator, and then we'll just answer these questions over here. Okay? All right, so first of all, go to your y equals button on your calculator. Now, there's already some stuff in there, so a couple of things. I don't really want any of the stuff that's already been graphed in there, so I'm going to clear it out. Another thing, notice that plot 1 is all bold and on. That's because I was using this to do some statistic stuff earlier. I don't want that statistic stuff anymore. I don't need to go clear out my list or do anything like that. I just need to go up here and turn it off. So I'm just going to press Enter on top of it so that now none of those things are highlighted. And now the data won't show up in the graph because that's not what I'm focusing on. Okay? Then I'm going to go ahead and enter the equation that was on your note guide. So it was negative x squared plus 6x plus 3. So notice this is the only thing that's bold. Its equal sign is bold right here. That means it's the only thing that's going to show up on our graph. So I'm going to go ahead and press graph at this point. Now, I might have a little bit of a problem. So I press graph, and notice I don't see anything. Does anybody know why I'm not seeing anything right now? Yeah, sure. Good. So the last time I used my calculator, I changed the window to specifically be able to see those statistics that I was graphing. And that's probably not the best window to see this. So a couple of ways to fix this. My first thing is to kind of go back to the standard window. So I'm going to go zoom, and I'm going to choose choice 6. And that's going to go back to like 10 in every direction. Now, I can see my parabola, but it's still not the best window because though I can see the intercepts pretty well, I can't really see the maximum at all, and I don't really need to see all this extra stuff over here. Okay, so me personally, I want to see more, okay, up there. I don't need to see as much down here if I don't want to, and I definitely don't need to see as much over here. So the way that I'm going to adjust that is I'm going to adjust it by hand by going to my window. So go to Window. So I said on the x-axis that I didn't need to see all the way over to negative 10. Maybe I only need to see over to like negative 3 or something. Okay. But positive 10 is a good choice because we needed most of the stuff that was on the right. And x can still be scaled by 1. The y minimum, I can keep it at negative 10. I could change it to something like negative 5 if I don't want to see so much below the axis. And the y maximum, I need to try something new. Does somebody want to pick something that we could try? 15? Okay, so I'm going to push 15, and I'm going to push graph. Sure. Okay, we got the vertex, so it's good. Now, if you are really struggling, given that your equation was in standard form, does anybody remember the formula that will tell us the x-coordinate of the vertex? It was kind of in our PowerPoint overview. What's the little formula that tells us the axis of symmetry as well as the x-coordinate of the vertex? Good. Negative b over 2a. Now, that would give me the x-coordinate. How would I get the y-coordinate once I got that number? Good. Plug it back into the equation. Now, you might think, well, then I just have the vertex. Yeah, but if you didn't know where it was, if it was taking you a long time to find it with your window, wouldn't it be kind of helpful to know where the vertex was, and then you could set your window around that? Okay. So use the knowledge you have. Somebody asked, I don't know if it's this period or another period, like, why do we need to know this if the calculator can do all of this for us? The person operating the calculator has to be able to interpret the information and use the machine to view the information in the most proper way. The calculator is only as smart as the person operating it, okay? Yeah, and exactly. People write stuff to make them do this. But I wouldn't want somebody plugging numbers into a machine that had no idea about engineering, who's like working on a shuttle or something to launch into space, that just prints stuff out and hands it to people because they can run a machine. I would want them to know about the mathematics they were supposed to see, so it could like know if it makes sense and something like that. I'd want them to use the machine, so it takes like half as much time as it would take otherwise. But I would want them to know what they were doing mathematically, not just how to press the little buttons and take a little printout to somebody else, you know? All right, so now that we have a good view of the graph, okay, we're going to go ahead and use the keystrokes that find things on the graph, okay? So our goal is to find the x-intercepts and also to find the vertex. So let's talk about the vertex first, okay? Is our vertex in this case a maximum or a minimum? Is it a maximum value of the graph or a minimum value of the graph? Maximum. The graph does not go past that vertex. That's important because when we find things on the graph, we do them through the calculate button that's up here in the graphing key. So we're going to go second, calculate. And what the calculator does is it's been programmed with some calculus operations that it can do to narrow down what your maximums and minimums are based on your equations and some things that are near the maximum and the minimum, okay? So we are going to calculate a maximum, so we're going to choose choice 4. And then what the calculator does is it puts the cursor on the curve and it asks you for something specific. So in this case, it says, what is the left bound? So what it's saying to you is you can see the maximum on the screen. Take the cursor and put it somewhere that would count as a boundary on the left side of the vertex. So you're going to go ahead and scroll using the left and right buttons till you get to a place that you would consider left of the vertex. Okay? How far left is up to you, but something that you would say this is a boundary on the left of the vertex point. Okay? When you're there, you press enter, so the calculator will record that as the left boundary. Okay, it put a little arrow. You can't see because our cursor is there right now, but when we move our cursor, you'll see. Now it's asking us the same question, but it wants a right boundary. So now we're going to use our arrows to make sure that we trace the graph but go to the right of the vertex point and press enter somewhere that would count as a right boundary. So what we've done is we've just told the calculator, hey, the vertex, the maximum, happens somewhere in between here. Go work your magic that we don't know yet because we haven't taken calculus. Do your little operations and figure out with our equation and these boundaries what must be the maximum point of this graph. So then it says guess. I don't think this really matters, but you can put your cursor where you kind of think it is and press enter. Then what your calculator does is it does its calculation and comes up with this. Now, 2.9999983, what are we going to call that? 3. Now, if it was just 2.9, I wouldn't assume that it was 3. But when it's 2.99999 repeating so many times, I'm okay with rounding it to 3. So we're going to go ahead and call our vertex for this graph 312. Okay? So record that point in the chart where it said what the vertex was of the graph. So again, we graphed it. We used the calculate graphing button, and we chose maximum, and then we just had to fill in the boundaries. Okay? Yes? Okay, so again, the calculator is using your boundaries and performing a calculation. So way out there, it might be slightly different because it's actually using something called like an approximation, but the approximations are pretty accurate. I would round 3.00000 also to 3, but it's just because you didn't push the same exact boundaries that I did. Okay. All right. So the next thing we're going to do is we're going to find the intercepts. Should we go somewhere else for now? Okay, so we're going to find the intercepts, all right? So let's go back to the calculate. Anything we want to calculate on our graph, okay? We're going to get through there. Which of these things do you think calculates x-intercepts? So number 5, intersection calculates the point where two different things that you have graphed intersect. Okay? It's different between intercept and intersect. Okay? You're not allowed to guess, Dylan. All right. So which one up there is going to work? Look back at your vocab. I know you know, but I'm not letting you answer. Look back at your vocab, okay? What is another word for x-intercept that we see up here? Zeros. Good. So I'm choosing choice 2 this time, 0. Now, I'm going to have to do this for as many intercepts as there are. So there are 2 intercepts. You can't find them both at the same time. Okay? You focus on one, you follow all the directions to calculate one, then you have to start the whole process over to calculate the other. Okay? So I'm going to go ahead and do this one that's on the left. Okay? Notice again, the first question it asks me is left bound. So it's asking me the same thing it asked me last time, but this time I'm trying to find this 0 that's somewhere around here. So I kind of position it near the 0, and then when it asks me for left bound, I press the left arrow a couple times and press enter, and it'll mark something that's to the left of that 0. Then it says right bound, so again, I press the right arrow a couple times so that I'm past the 0 and to the right of it, and press enter. Notice it marked my arrows at the top. Make sure they make sense. Is your 0 between the 2 arrows that you've marked? It should be, okay? And they should be facing each other. So then it says guess. Yeah, I want it to guess. Okay, so one of my zeros is negative 0.464. Okay, so that's one of my intercepts. So go ahead and record that. If you record it as a point, it should be negative 0.464, 0. Or you could say the x-intercept is negative 0.464. Okay. All right, and then you guys go ahead and find the second x-intercept. So you need to do the process we just did again. Okay, so go ahead and do that. What was it? Negative 0.461 or 106? 464.16. Who's found our second x-intercepts? Michael? Can somebody confirm that 6.464 looks good? Yeah? Okay. All right. Now, they won't always match the decimal part. This just means, like, if you use the quadratic formula, the whole number part was probably, I don't know, something between 0 and 6, and then adding or subtracting that radical made this decimal thing come at the end. Sometimes they'll match, sometimes they won't, because it just depends the way that the problem worked out when you add and subtract stuff. Okay? All right, from this information, can somebody tell me what the axis of symmetry must be of my quadratic? So you saw it on the graph. You have this up here. Good. So x equals 3 will be the equation for the axis of symmetry. Okay, the maximum or the minimum value. So I kind of made a deal about this last time, that there's a maximum minimum point, but then there's part of that is the value, and part of it is where the value occurs. So what is the maximum or minimum value? Jack? 12. Good. The maximum value, right? All right, what is the domain for our function? Sure. Okay, yeah, good. So you caught yourself. So did you guys hear what he said? He said x is less than or equal to 12, and then he said, wait a minute, that's a y coordinate. So who thinks that they have the domain? Yeah, Damien? Mm-hmm. The 3 as a bracket? Okay. I want you guys to take a minute in your group, see if you agree with Damien, if you would adjust the domain and figure out what the range is. And try to write it in a notation with an inequality and then also in the interval notation. Okay? So take like 30 seconds to a minute in your group to figure out. Okay, adjustments we want to make. So, does anybody feel like our domain is good or they want to adjust it? Comments on the domain. Stephanie? Okay, so yeah, if you were using an inequality notation, we would use all real numbers. How does that address or adjust our interval notation that we have up here? So? Good. Okay, so it should go all the way to positive infinity, and then we can't close it with a bracket. Okay. So remember, when our parabola is concave up or concave down, it still goes to the left or right for all values. Okay, no spaces, which is why from negative infinity to infinity are all real numbers. What did you guys come up with as the range? Michael? Okay, so one comment. This is good. Y is less than 12 or equal to. Good. Which means we do want a bracket here, but should it be the number 3 here? What number should be there? 12, the same number you were talking about in your inequality right here. Okay? Is this all right with everybody? Yes. Saying that you actually reach 12. 12 is included, like a closed point on a graph instead of an open point. Okay? All right. What if we had to graph this graph by hand and our calculator didn't do it for us? So what do those steps look like? That's our second question. So you guys answered part of this question when we were trying to set our window for the graph. Okay, and I said, well, it would have helped if we knew the highest point on the graph. So a couple things about this graph. Just looking at the equation. Is the parabola concave up or concave down? Up. Okay, so we know some stuff, and our graph should look like this. When it's in standard form, we wanted to start by finding that vertex. We were able to find it. When I put up the equation to graph on the calculator, you guys were able to tell me how I could have found the vertex if just kind of changing the number didn't immediately get me to the height that I wanted. So what was the formula that Denise had told us helps us find the axis of symmetry? I see Jarrett, Carly, Austin. Good. So our axis of symmetry, when it's written in standard form, when we can identify the A, B, and C, we can use this formula where we use B and A. So A is 4 here, B is negative 16, and C is 10. So our axis of symmetry, messy. My negative 16 over 2 times 4, which will be positive 16 over 8, which will be 2. So the axis of symmetry for my graph is x equals 2. So on the graph, that means that I would mark it with this vertical dashed line at x equals 2. Now, if I have the axis of symmetry, I should be able to find my vertex. So my vertex is an x and a y coordinate. What can somebody tell me about my vertex so far? CJ? Good. The x coordinate is 2. Otherwise, it's not going to line up on the axis of symmetry. Okay. How do I find the y coordinate that goes with this x coordinate? New people. Someone I haven't called on yet today. Called on Carly and Jared. All right, Zeke. Good. I'm going to plug the x into the equation. So I'm just going to take the equation however it was given to me, and I'm going to plug in this x value. So I get 2 squared is 4. 4 times 4 is 16, minus 32 plus 10. 16 minus 32 is negative 16, and negative 16 plus 10 is minus 6. I thought you were telling me to subtract 6. Let me just yell things out. Okay. So I get 2 negative 6. Okay. 1, 2, 3, 4, 5, 6. All right. So I have this information. What do I need to do now? Am I done with my graph? No. Okay, some people leave it like this. Not a good idea. What should go on the graph? Okay, some more points that should form a parabola that faces upward. How am I going to get some more points? Jarrett? Good. Now, I could find the intercepts if I want, but we talked about how that's not a must when you're graphing, because are the intercepts always going to be nice points that are easy to graph? No. Okay? But if I have this middle stuff, my axis of symmetry, my vertex, I can just plug in x's near that and find the y's that go with them. So for example, I'm going to try what happens when x equals 1 to find 1 comma something. So I'm going to take my equation and I'm going to plug in 1 for x. And then I'm going to finish the calculation for y. And so I have the point 1 minus 2. And I'm just going to mirror that on the other side of the axis of symmetry. And that's enough for us to graph this. Okay? So is this all right with everybody? So over the weekend, you did homework on transformations. So there you kind of started with a parent, and all the numbers just meant a shift, a stretch, a reflection, something like that. Here, you're going to do a calculation to start getting points on the graph and approach it a little bit differently because you don't have all the transformations to look at. Okay? So we should develop both those skills, and that's kind of our goal with graphing right now. All right. Last example is not to graph it, but to answer a question in some sort of context. Okay? So they say a model for the performance of a stock is given by this equation. So P equals negative 3D squared plus 50D, and D represents the days of trading. So if I want to find out where the stock is after 5 days of trading, I plug 5 in for D, and I'll calculate some sort of P that will give me the performance of this stock. Okay? Does that make sense how it generally works? Okay. So they're giving you the equation. Then it says, what is the maximum price per share of the stock? So you want to find the maximum p-value that occurs. Okay? So I want you to think about how the equation behaves. So you look at the equation for p. Is it linear or is it quadratic? If you graphed the equation for p, is it going to make a line or is it going to make a parabola? Parabola because of the d squared. So is it linear equation or is it a quadratic equation? Quadratic. So if it has something squared, it's in the quadratic family. This quadratic equation, once you graph it, will it be concave up or concave down? Concave down because of the negative 3 at the beginning. So I don't know what this graph looks like, okay? But there's some, I really have no idea. I'm just throwing this out there, okay? But it goes like this, okay? Is that fair enough to say? Just in general, okay, the shape of the graph. So when they ask me, what is the maximum price per share of the graph, think about what's going on. D is what you're plugging in. It's kind of behaving like your x. So your D values are along what we normally consider the x-axis. And what is the y-axis representing here? P, okay, the price that is the outcome. So when they say calculate the maximum price, what are we really looking for in this parabola? The vertex, okay? Because see how it's concave down? So it has a maximum, and the maximum will occur, at the vertex point right there, okay? So this vertex point has some D coordinate and some P coordinate, okay? And we're trying to find the maximum price per share. We don't want to list the whole vertex as the final answer to this question. We really just want to know what the p-value is of that vertex. Does the thinking part of it make sense? Yep. Because the graph was a parabola and face down, there is a maximum. I'm just understanding the maximum is a vertex. I don't have to graph the whole thing to figure that out. So then the question is, how am I going to figure out this value? So how do you take a quadratic equation and figure out its vertex point? I see Jarrett's hand, but he answered a lot of questions about this. I'm not going to let him answer for you guys. So how am I going to take this equation and find that vertex point? See? Yeah, I'll start with negative b over 2a, and what will negative b over 2a give me? The x-coordinate, the axis of symmetry, and the x-coordinate of the vertex, which is a d value. And then how will I get the p value that goes with that d value? Plug it back in, okay? So I'm going to go ahead and start with 10, Totally running out of batteries, sorry. Not me personally, but my pen. All right, so negative 50 will be in my numerator, and 2 times negative 3 will be in my denominator. So negative 50 over 6. Yeah. All right, so I could reduce this a little bit if I want, or I can get a decimal value. What's 50 divided by 6? You guys have calculators on your desk. What's 50 divided by 6? Okay, so like 8 and 1/3. Okay, so go ahead and plug that in for D and tell me what you get for P. Okay? So you're doing this. You don't really have a 3 bar on your calculator, so you have a couple of choices. You can put it in as a fraction, or you could put a lot of 3's there and kind of figure that that's going to be good enough to approximate it. So somebody let us know what you get. So what did we get as P? Stephanie? 280.3333. Is that what you said? 280? Oh, 208. Thank you. That's okay. I just couldn't hear. 208.33333. Okay, so this is the answer to their question, right? The maximum price it would reach is $208.33, or whatever. And then what if I added another question? When will it reach this maximum value? How would you answer that question? So it reaches a maximum value of $208.33. When will it reach that value? Good. After 8 days of trading. Right? So if you had seen a similar stock in the past and you could predict, like, oh, I think it's going to behave like this one and take data, then you would do that, and after 8 days you would trade because you would feel like it was at its maximum value. So that's how you could apply something like this. Okay? All right, I'm going to